Hello friends, today we are going to discuss about robotics concepts. Myself is Sadat from Alexander Polytechnic Mechanical Engineering branch, a senior lecturer and international corporate trainer. So friends, today we will be having the concept of robotics. So let us see how the robots will be. So this is what we are going to see, that there are different varieties of robots we have been seeing. This is robots might be used in as a industrial pick and place purposes, or even nowadays robots are being used in domestic use also. Let us see today's agenda. So today we are going to discuss about overview of a robot, and then next we have what are the different applications, then advantages of robots, uh, robot anatomy, robot physical configuration, then 6 degree of freedom. So next we can see that there the technical features of robot, then components of a robot, programming of robot, and industrial applications of robots. So the introduction about robotics. So a robot, as you can see, that it is nothing but a reprogrammable or a multifunctional manipulator designed to move material parts, tools, or a specialized devices through various programmed motions for the performance of variety of tasks. So you might be seen that in a number of places that nowadays in every industry they are switching towards the robots might be used for taking material from one destination to another destination, might be for displacement of the tools, or might be from taking the parts from one place to the another place. So these robots can be reprogrammed for the different purposes. So basically a robot consists of, okay, let us see what a robot is having. A robot is having a mechanical device such as a wheel, a plate, forms, arm, etc. So it is having a sensor system that process sensors as an input. So the basic mechanical device plus sensors and a processing unit. Then the two main components, that is nothing but the first part is the body of a robot, and the next is the artificial intelligence that is used with a robot. So this is what we are going to discuss in the next slide. So now what actually a robotics is, this is nothing but the study of the design of a robot, how a robot can be used, right? Here we are going to see that the design and construction of the robots. And in artificial intelligence is a branch of computer science that deals with the writing of computer programs. So these programs will be written so that how a actual robot to be worked. So whatever the program is written, on that basis the robot is going to work. It might be a pick and place, or it might be a multiple task. Maybe a robot can be used to even for welding process or welding purposes. Now you can see that the different applications of a robot. So robot is having a variety of applications. The basic thing is that the handling of a material, then it will be even utilized as a welding, arc welding or a spot welding, and even the laser cutting, then spray coating, gluing, investment casting, process operations, assembly, inspections, machine loading and unloading. So these are the applications of a robot. Next, what are the advantages? So let us see that why nowadays the industries they are replacing the human being with the robots. Now you might have seen that there might be a situation where a human cannot go or a human being may be tired or getting sick in the hazardous places. So these are the some of the advantages that a robot can be used. So robot basically used can be used for repetitive task, means repetitive process can be done with the help of a robot. Same type of operations from morning till evening or even 24/7 the robot can be utilized. So robots can be operated equipped to main much higher position than a human. Robots never get sick or it never get tired. A robot can do a task considerably too dangerous and hazardous places where a human being cannot go. There robots can be sent, and easily these operations can be carried out even in a war places. So they will get a photo images of a war, may be able to perform the task that is they are impossible for a human being. And even these robots will not go for any strike or lockdown or anything that they required a hike in salary, anything like that, because a robot, they are the machines, programmable machines, work like a human being. Now let us see the anatomy of a robot. As you can see the image of a robot, that is, you can just think of that it is nothing but a human arm. Okay, so now let us see what actually these robots have. Industrial robot consists of series of joints and links. So this is the very important concept of a robot, that is it has a joints and a links. Let us see what actually these joints and links will be doing. So robot anatomy is uh, concerned with the types and size of these joints and links and other aspect of the physical configurations. The very basic important concept that it is having the joint and the link. Now this is what you can see in the sketch, that the things that this is the known as a joint which is connected with a link, and from here, from bottom till this end, you can see that it is connected with a link joint, and then a link and joint, then the end arm. So this is the very important concept, that a robot is used with the help of these joints and the links. It is meant for manipulating, or it is also known as a manipulators. Joint provides relative motions. So these joints, you can see, they will provide the relative motion between these two links. Links are nothing but they are rigid member between the joints. Various joints, that is a linear or a rotary joints. Each joint provides a degree of freedom. So even the most of the robots nowadays is having a 6 degree of freedoms. So this is what you can see, that there are different links and the movement of the robot. So robot arm for positioning of an object in a robot works volumes. Wrist assembly for orientation of an object. So this is what you can see, that the movement of a robot might be linear, rotary movement, orthogonal movement, and then twisting movement, and then revolving movement. So these are the different manipulator joints. So this is the transitional motions, that is, you can see that if you see a type L, that is known as a linear type, and the orthogonal is an O type, and for rotary motion we have a 3 types, that is, you can call it as a RTV, that is a rotational, twisting, and revolving. So these are the motions, rotary and transitional motions of a robot. Next, this is the configuration, that is the robotic configurations. Robot manipulators are divided in two assemblies. So that is, one is a body and a arm assembly, that is having a 3 degree of motion, and the next we have a twisted assembly which is having 2 to 3 degree of freedom. So this is what the body, and this is what the assembly, wrist assembly. Now coming to the configurations of body and arm, right? So this is a robot is having different configurations. this is what we can see, a robot with a polar coordinate, a cylindrical, Cartesian, a joint arm, and a SCARA. So now we can see that this is the robot, polar coordinate configuration robot. Here we can see that the motions we have is a T, R, and L. So that is what you can see. The base is having a twisting movement, and then we have a rotary movement, and then a linear movement. So this is having a movement that is in polar movement. So this type of robot is even called as a telescopic robot. Next we have a cylindrical configuration. So this is what you can see. Here we have a cylindrical face, that is we can see this is a T, that is a twisting, and then L a linear, and here we have a orthogonal motion, right? So this is, we can see, that is O, L, and T. Next we have a Cartesian coordinate. Here additional thing is that it has a two orthogonal and a linear motion, right? We can see that here it consists of three sliding joints, two of which are orthogonal. Sliding is in two direction, that is one two orthogonal, and it is this includes a rectilinear robot XYZ directions, and a robot which constructed around this configuration consists of three orthogonal slides as shown in figure. Okay, so this three sides are parallel to X, Y, Z axis. So this is a Cartesian where we can have a three axis motion, that is X, Y, and Z. Next you can see that this is a joint arm configuration. It is nothing but it is just a combination of a cylindrical and a articulated configuration robot. Here we can see we have a twisted rotary, and then multiple rotary motions are there, because we can see here also we can have a rotary motion, and also here also we have a rotary motion with a twisted type. So this is the robot arm is mounted to a base which can be rotated to provide the robot with a capacity to work within a quasi spherical space. So this is as if we have a you can see that our human shoulders, like elbow and a wrist. Next, a SCARA robot. So SCARA stands for selectively compliance assembly robots, and this is similar to joint arm robot. Here we can see it is having a R, V, and or O. So this is this type of robots basically used very in what you call, you can have a welding process or holding for a particular task, and even this can be used to compliant in a horizontal direction or in a vertical insertion task. So this is what we can see, that wrist configurations. So this is the end effectors, or this is having a 3 degree of motion. So here we can see this is what a roll which, and a yaw, and a pitch. So this is attached with the arm. Wrist assembly is attached to end arm, end effector is attached to a wrist. So whatever the end effectors are attached, so they are attached with the wrist. The function of wrist assembly is to orient end effectors, that a body and a arm determines global position of a end effectors. So here we can see that a roll is there, and then we have a yoke, that is using T joint, pitch using R joint, and yaw R joint. Next we can see that the robot motions. Robot motions, whatever the configuration, the purpose of the robot is to perform a useful task. To accomplish the task, end effectors or a hands is attached to end of the robots, right? The robot complete body for holding process, for holding purpose and doing some particular task. So it is required the end effectors, that is what we can call it as a robot hands. So as you can see, there are number of grippers are there, so that can be called it as a robot hands or robot fingers. Yeah, so here we will conclude this session, and the remaining topic will be in the next video. Thank you.